Good morning, students. Welcome to the online video lecture on the topic game theory. In this video, we are going to discuss the problems on pure strategy using max mini and minimax principles. Here, the first problem. Solve the following the game with the payoff matrix. In the examination, they are going to give the problem in the payoff matrix. Here, player A, player B, there are two players are there. A1, A2, A3 are the strategies for the player A, and B1, B2, B3, B4 are the strategies for player B. Then 1 7 3 4 5 6 4 5 7 2 0 3, these are all we can call it as payoff. That means the A1 to B1, that is 1 is there. If the player A uses A1 strategy, player B uses B1 strategy, the outcome of the strategies that we can call it as payoff, that is 1. And for 7 A1 to B2 7, if the player A uses strategy A1 and player B uses B2 strategy, then the payoff is 7, like this. The elements are in the payoff matrix, those elements are outcome from the strategies. Okay, here the problem is having player A and player B. Player A having three strategies A1, A2, A3, and player B having four strategies B1, B2, B3, B4, and he has given the payoff, that you can call it as elements in the matrix. Now, the first step. Here the first step is what it says, that find out the max mini value. When it comes to max mini value, it is concerned with the row wise. Okay, in the A1 row, now first tell me in the A1 row which one is the minimum element? 1. In the A2 row, the minimum element is 4, and in A3 row, minimum element is 0. Okay, 1 4 0 are the minimum elements in the every row. Among those minimum elements, you need to choose maximum element. That maximum element is 4, that we can call it as max mini value. In the next step, we need to find out the minimax value. It is concerned with column wise. In the B1 column, choose the maximum element, that is 7. In B2 column, again 7. In the B3 column, we are having the maximum element is 4. Now in the B4 it is 5. Among all these maximum elements, which one is the minimum element? That is 4. That we can call it as minimax value. Okay, in the first step we need to find out max mini value. In the second step, minimax value. Now comes to the conclusion here. First, the max mini value is equals to the minimax value. Okay, max mini value is 4 we got, and minimax value is also 4, so that the minimax value is equals to the max mini value. That indicates what? Saddle point is exist. If it is not equals, then it is saddle point, it is not exist, but here it is saddle point is exist because of max mini equals to minimax value. Now here max mini's value is 4 and minimax value is 4. Now tell me where they are going to intersect. They intersect at A2 to B3. A2 B3 cell. That cell element is also 4. Okay, that cell element is also 4 here. That indicates what? 4 is value of the game. We can call it as, we can encircle that element Okay, that we can call it as value of the game. Okay, see here the intersection point max mini value is in intersection of the max mini value and minimax value at the cell that is A2 to B3 cell, that is element is having 4, that 4 is we can call it as value of the game. Now tell me here the value of the game is equals to the 0, then that game we can call it as fair game. If it is not equals to 0, then we can call it as strictly determinable game. Here we got value of the game is 4, so that the value of the game is not equals to 0, that then game you can call it as strictly determinable game. Now comes to optimal strategy. Here the optimal strategy for the player A, the value of the game that is 4 is occurs at A2 row, so that the player A chooses A2 strategy. When it comes to player B, the value of the game occurs at B3 column, so that the player B is uses B3 strategy. Now the value of the game is 4. See here another 4 is there in the payoff matrix, that is at the cell of A1 to B4, another 4 is there. Okay, so that value also we can consider as value of the game because of the same elements that we are going to consider here. Okay, first we got 4 at the intersection point max mini value and minimax value, and another 4 is there at the A1 B4 cell, so that the player A uses A1 A2 strategy and player B uses B3 and B3 and B4 strategies. Okay, here the value of the game is 4 and saddle points are A2 to B3 and A1 to B4. Next, go for second problem here. Here also the player A having 3 strategies A1, A2, A3, and player B also having 3 strategies B1, B2, B3. Now apply the max mini and minimax principle here. Find out the value first here. Max mini value. From the A1 row we are having the minimum element is 2, A2 row it is -3 and A3 row -2. Among these minimum values, which one is the maximum? 2. That we can call it as max mini value. When it comes to column wise, choose the maximum value. B1 it is 3, B2 2 and B1 is 4. Among these maximum values, choose the minimum value, that is 2. Okay, now max mini value is equals to the minimax value here. Yes, then it is 2 and 2, so that the saddle point is exist here. Now can you tell me the value of the game here? Please check it, the intersection of minimax value and max mini value at the cell A1 to B2. Okay, that is 2. Okay, 2 is the value of the game. Now the value of the game is not equals to 0 here, it is equals to 2, then that game you can call it as strictly determinable game. Now can you tell me optimal strategies for the player A? See, the value occurs at A1 to B2 cell, so that the value of the game is occurs at A1 row, so that the player uses the optimal strategy for the player A is A1. When it comes to optimal strategy for the player B, the value of the game is 2 occurs at B2 column, so that the optimal strategy for the player B is B2. Okay, now winner of the game. How are going to find out the winner of the game means the value of the game who are getting here, it is 2. 2 is the positive value. Okay, if it is positive value, then it indicates that player A is the winner. If suppose if you got the negative value, then the winner of the game is player B. Okay, if it is positive value of the game is positive value, then it is winner of the game player A, and if it is negative, then player B is a winner. Now third problem. Again here we are having two players, player x, player y, and x1 and x2 are strategy used by the player x, y1 y2 strategies are used by the y. Now same apply the max mini principle here. In the x1 row we are getting minimum value is -2, and in the x2 row -1. Among these two, which one is the maximum value? -1. And similarly go for column wise, choose the maximum value. Y1 it is 2, y2 is -1. Among these two values, choose the minimum value, that is -1. Max mini value is -1 and minimax value is also -1. Both are equal, then it indicates saddle point is exist. Now tell me the intersections of max mini value and minimax value at the cell of x2 y2, that is -1. Okay, the value of the game is, here it is -1, so it is in the negative, so that what it indicates here in this game, the winner is that is player y, because we are getting the value of the game, it is in terms of negative, so that the that indicates player y is a winner. Now tell me the player x, which strategy that is used, that is x2, because of value of the game is occurs in x2 row. For the player y, that is optimal strategy for the player y, the value of the game is occurs at y2 row, so that the strategy is y2. Now value of the game, it is -1, it is not equals to 0, so that what it is, the game is strictly determinable. Now the next problem, see here also we are having player a and player b. Player b, that is your player a having 1-2 strategies, player b also 1-2 strategies. Find out the values. Max mini value here we are getting 0, and minimax value we are getting 0, so that max mini value equals to the minimax value, so that saddle point is exist. Now check the intersection point of the minimax value and max mini value, at the row 1 and at the column 1. Now the value of the game is, that is 0 at the 1 cell, that is 0 here. Now the type of game it is a fair game, because of the value of the game is 0 here. Now optimal strategy for the player a, the value of the game 0, it is occurs at first row, so that the value of the optimal strategy for the player a, that is 1, and optimal strategy for the player b, that is value of the game is occurs 0, it is occurs at column 1, so that optimal strategy for the player b is also 1. Now winner of the game, the value of the game that we are getting 0, so that we can't predict the winner here. The 0 that indicates either or neither both the player, either it may be player a or either it may be player b is a winner. Now the last problem, that is again player a and player b. Here 3 strategies are there, here also 3 strategies are there, player b, and max mini value here we are getting 7, and minimax value we are getting 7, both are equal, then the saddle point is exist. Now check the intersection point of these two, max mini value and minimax value, that is at 7, a2 to b2 cell 7, that 7 you can call it as value of the game. The value of the game is 7, it is a positive value, so that the winner of this game is player a. Then and this value of the game is not equals to 0 here, you are getting 7, so that the game is strictly determinable game here. And optimal strategy for the player a, the value of the game occurs at a2 row, so that the player A uses A2 strategy, and for the player B, the value of the game occurs at the column 2 B2, so that the player B uses, that is B2 strategies. Okay, thank you. Next video lecture, that we are going to discuss the analytical method, where the without saddle point is exist. Okay, thank you.